Thanks for joining. Today we will show you how to build fully managed data pipeline with MongoDB Atlas and Confluent Cloud. I'm Nathan Nam. I'm a senior product manager covering Kafka Connect and connectors at Confluent. Here with me today, Rob Walters, who is a senior product manager for connectors at MongoDB. Data in motion, and more specifically event streaming, is a new category of data infrastructure, first developed at LinkedIn by the founders of Confluent. As we often see, the best technology makes their way through Silicon Valley, and today hundreds of thousands of developers and virtually every digital-first company leverage event streaming. And also, as often say, the very best of these technology make their way from Silicon Valley into the enterprise. Then today, over 80% of Fortune 100 companies use Apache Kafka, and majority of them are Confluent customers. And this truly is a new way of thinking about data. The existing paradigm of data is one where data is at rest, with the relational database being the center of your data infrastructure. This worked remarkably well for many years as it solved the enterprise need to query data and build the transactional applications. But today, this is no longer enough. Challenge today is not just querying a database. The challenge is connecting across multiple systems and silo lines of business. This results in most enterprises having an architecture that looks like this one. Here you see an untenable amount of point-to-point connections in a data infrastructure that is rigid, complicated, and expensive, making it too difficult, time-consuming, and cost-prohibitive to innovate. This is the exact visual representation of what it means to be restricted by your infrastructure. The new paradigm for data in motion is centered around event streams. Here, the data is not static or passive, but continuously evolving and continuously being processed in real time. Here, the fundamental notion of data moving, not sitting at rest. In today's webinar, we'd like to show how Confluent Cloud and MongoDB Atlas work together to simplify your architecture. To make this happen, we recently released MongoDB Atlas source and sync connectors for Confluent Cloud. These connectors help you drive analysis with the real-time data within a few clicks. And you can choose where you want to create fully managed data pipeline with these connectors since they are available on AWS, Azure, and GCP. Let me briefly explain today's demo scene. Your company, we'll call it Stock Trader, is a fintech company providing an in-depth analysis for various stocks, has run lots of MySQL databases to store almost everything related to the business. Recently, you adopted MongoDB Atlas, a cloud-native database. While you want to eventually migrate to MongoDB Atlas, it'll take time. You need a way to aggregate raw data in MongoDB Atlas until the migration is completed over the next couple of years. Confluent Cloud and its fully managed connectors provide an easy way to do so. In the demo, I will show you how to run fully managed Division CDC for MySQL and MongoDB Atlas source connectors to gather data from two different sources, and how to use KSQL queries to do a transformation, and how to run MongoDB Atlas sync connector to send the data from two different Kafka topics to MongoDB Atlas. Rob will show you what you can do once the data lands in MongoDB Atlas, such as using aggregation pipeline builder to author analytical queries, and showing you how to easily visualize your MongoDB data with the MongoDB chart. So let's get started. As the first step of the demo, I'll create a MySQL CDC source connector to fetch stock pricing information from MySQL database. I'll create new Kafka API key and secret. I'll provide my connection information for my MySQL database. I'll choose prefer as my SSL mode. Then I'll specify one database I have. For snapshot mode, I will select when needed. Then for output message format, I'll pick Avro. Then I'm only interested in the after state. Then I'll run this connector with the one task. Now Division CDC for MySQL connector is up and running. So let me quickly check the topic. Here is the topic created by MySQL CDC connector. Then let me just quickly check. As you can see, all the stock information is coming through. The record is a little cryptic because it's Avro format. So let me quickly check the schema. The connector was able to create the schema properly as well. Now we have a Kafka topic populated by MySQL CDC connector. So whenever there is like a new insert or update, any change in MySQL database for this particular stock table, it will be all populated in Kafka topic. Let me also quickly show you one of the important enhancements we made in networking side for MongoDBLive source and send connector. My organization is enabled for static egress IP. So if I go to my settings for cluster, then click networking, I have this 10 egress IPs available for my Confluent Cloud, and I added this IP addresses to MongoDBLive. So if you also wanted to use this, please reach out to our support team or account manager. If you are running Kafka cluster on AWS with the public internet option, you'll be able to leverage this new feature. As our second connector, I will create MongoDB source connector. I'll create a new Kafka API key and secret for this connector, and I'll use a Mongo as my prefix. Then I'll provide my connection information for my MongoDB database. Database name is called stocks, and I'm interested in this specific collection name called stock data. I want to copy the existing data from my collection, and I want this connector to create Avro schema automatically, and only interested in the record itself rather than verbose metadata. Then I want to fetch the full documentation when there's a partial change in MongoDB collection. And for output JSON format, I'll go with the default JSON, and we'll run this connector with one task. MongoDB source connector is also up and running. So let me quickly show you the topic. Here's the topic populated by MongoDB source connector. So you can see Avro data flowing through to this topic from MongoDBLive. Let me quickly show you the schema. The schema is also created and registered by this connector automatically. Now we have a two source connector up and running, one for MySQL and the other for MongoDBLive. Before we send these topics to MongoDBLive database, we want to do a simple transformation. I want to specify the origination of these record, one for MySQL and the other for Mongo. For that transformation, we'll use a case equal DB. I'll create the first initial stream for Mongo stock topics. And as you can see, this stream will have 5 different fields. This is the additional field I want to define for the origination of a stock information. Then this stream will be created based on the Kafka topic, mongo.stocks.stock_data. We create this stream. Now we have an initial stream. Then I want to specify the origination of this stock information. And I'll put Mongo for this stream. Let me just quickly check our stream for Mongo stocks. So quickly query this data. Pause here. Let me show you what it is. This is a stock pricing information from MongoDBLive, and as I mentioned before, this origination, we call it exchange, is from Mongo. Let me create another stream for MySQL stock information. First, we will create initial stream based on the topic populated by MySQL CDC connector. Then we will add origination called MySQL to this stream. Let's quickly check the newly created stream called MySQL_stocks. If we query this stream, let me pause it here. If you look at the origination or the exchange, it's called MySQL. Now we have this new 2 KSQL DB streams with the information including origination of this stock information. I'll create MongoDBLive sync connector to send those topics to MongoDBLive. I'll select the 2 topics we just created with the KSQL DB, and select the Avro as my input format and create a new Kafka API key and secret for this sync connector. And I'll provide my connection information for MongoDBLive, and I'll put these 2 different topics to one MongoDB collection called consolidated stocks. And I'll run with the 2 tasks for this connector. So MongoDBLive sync connector is up and running. So let me quickly show you this consolidated stocks collection from MongoDB side. As you can see, the exchange from Mongo and also the MySQL will be aggregated in MongoDBLive. Robert will continue to show some cool demo what you can do with these records.
In this demo, we will dive into some of the features within MongoDB Atlas, first looking at the query capabilities, followed by a brief demo of MongoDB Compass. Compass is a GUI-based tool that can be used with any MongoDB cluster, including MongoDB Atlas. It brings the power of the command line shell into a GUI environment, enabling you to visualize document structure, build queries and indexes in a user-friendly way. Finally, we will explore what makes Atlas a platform, taking a look at Online Archive and MongoDB charts. What you see here is a web-based MongoDB Atlas portal. I have a few clusters that I am not currently using, and I pause them so I can retain the data without running the cluster. The webinar cluster is the one that Nathan has used to write Kafka data from the Confluent cloud. Let's first take a look at the collections. So I'm going to click the Collections button. And you'll notice the Consolidated Stocks collection. It's showing me a sample of my documents. You'll notice that I can specify a filter here in my find. So if I wanted to just look at company symbol, for example, and only the symbols that matched ACL, I can do that and click find, and I will get a sample of the documents that match this particular search criteria. But MongoDB has the aggregation framework, and within the Atlas is the aggregation pipeline builder. And you'll notice here that I have a sample of my documents in this collection. So here's a preview of the documents in this collection, and I can come here and start building out my different pipeline stages. For example, I can come in here and do a dollar group. So what if I wanted to build a query that's going to show me the average price for my company symbols? So I'm going to specify the dollar group. I'm going to group it by the company symbol. And I'm going to call this field, average price. And the accumulator we'll use is the dollar average. And the expression here is going to be price. So what you see is listed by company symbol is the average price for all of the data that's in my collection. I can continue adding stages. So for example, if I wanted to do a dollar sort, and come down here and do a dollar sort, and I'm going to sort off of that underscore ID field. Now it's sorted alphabetically, so you can see all of my stock symbols here and the the ascending sort order. So now that I've gone through and I've built out my pipeline, how do I get this into my application, or how do I make use of this? So up at the top here, it says Export Pipeline Code to Language. I can click on that button. And you'll notice that my pipeline, if I'm using the command line shell, I can copy that and paste it in. If I'm using a specific language, like Java, for example, I can click on Java and I will actually have the code that I need to import into my application. So on the bottom, I included the import statements and the driver syntax. And so here I'm pretty much ready to go. I can just copy and paste this right into my code. In my example, I'm going to use the command line shell. So I'm going to click on copy under my pipeline, and I'm going to open the MongoDB shell. So if you are not aware, MongoDB has released MongoSH, which is an updated version of the Mongo shell. That is also available for download on the MongoDB website. So you'll notice a couple of things about it, namely the color coding, and by default we print JSON result sets. So here I made my connection to my MongoDB Atlas cluster, and I'm going to use the stocks database. I'm going to show collections. So here I've got my consolidated stocks. So I'm going to do db.consolidatedstocks.aggregate. So now that I've copied that pipeline to my clipboard, I can just simply paste it in here and hit enter. So now it provides a really easy way for me to build out these queries. But what if I'm using a query, for example, that's a little bit more complicated? So say, for example, I am going to do my search command here. So let's go show my collections again here. I have consolidated stocks. I'm going to use that same one again. So here's my consolidated stocks.aggregate. And I pasted in another query that's a little bit more involved. So this is the one where we are taking that timestamp, converting it to a ISO date, and adding it a new field that is just the date itself without any hours on it. So it's adding a new field and converting the data type. So if I do that, I'm going to issue this query, and it's going to provide me a list of the days and the number of stock transactions within each day. So what if I wanted to go and troubleshoot this query, or if I wanted to add to it within the command shell? It's a little bit tedious because I have to, move around and things like that. However, what I can do is I can jump back to the Atlas shell here, and under this drop down, we could say new pipeline from text. I can paste in that aggregation pipeline and hit create new. It's going to say I'm going to delete what I just did from my unsaved work. That's fine. And now you'll notice that I do have each stage of that pipeline is now broken out into its own segment, into its own pipe, where I can come through here and modify and change this query in a much easier user interface. So what if you don't want to give access to the Atlas portal to your developers or whomever is using that? There is a tool called MongoDB Compass. Compass is a separate download. You can use it for any MongoDB cluster, not just Atlas. And it is available as a download on the website. Once you install it, what you'll get is this user interface. Now, I did make the font bigger, so it looks a little large on the screen here, just for this purposes of this recording. When you make a connection to it, you can see I have all of my collections and databases listed here. If I click on the consolidated stocks collection, you'll notice that I have some metadata about the number of documents, index sizes, and so forth that is located here. Very similar experience to the Atlas shell, where I can come in and create a filter. I can also create my aggregation pipeline here. And so just like in Atlas, I can create a new pipeline from text, paste in my pipeline, create new, and just as I did in Atlas, I can come in here and work on my MongoDB query. There is some other capabilities in the Compass. For example, I can click on schema, and what this is going to do is analyze the documents for a particular schema that is the documents are leveraging. So if I come down here, you'll notice that it does provide me some statistics. So price, for example, about 15% of the data has values between 40 and 45. So it does a really good job in terms of like analyzing the data to give you some basic metadata about the data. If you had geospatial data in here, for example, it would actually show you a map of the world and the data points that are mapped out on that and so forth. So it's pretty powerful. You can also look at explain plans as well as define indexes on your data. One thing you might have noticed at the bottom of the Compass dialog is the MongoSH beta. If you scroll up, you'll notice that we do have a complete Mongo shell right here embedded in the Compass dialog. So I can come in here and type in my db.stocks.find, and you'll notice that the data is color coded and provided here for me. So it's a full shell. I can do anything I can do normally in the MongoSH shell within Compass. So Atlas is more than just MongoDB cluster as a service. It's a platform that includes many capabilities, such as Atlas Search, for example. So Atlas Search is a fully integrated Lucene search engine within your cluster, making it easy to build applications that provide search relevance and autocomplete capabilities. Another feature within Atlas is Atlas Online Archive. So you have a lot of data from Kafka and from other sources that are inserted into MongoDB. And this data, not all of it is warm data. Some data eventually gets aged out, but you need to keep it and retain it. And in certain cases, you might need to query that old archive data. And that's why we have Online Archive. So with Online Archive, what you can do is define a query that will run. It will take your data and copy it over to S3 bucket. From there, that data will seamlessly migrate over to that S3 bucket, and your applications will continue to run. And you have the ability then to query that cold data and warm data from a single connection string. So as I configure my online archive, I first provide the namespace. So the namespace is my database and collection name. and it's going to specify the date field that we'd like. So I'm going to use my tx time here, and it will auto archive after, say, 30 days, and it's going to specify the format, whether it's an epoch time or an ISO date. So once I set this up, I'm going to click next. It's going to provide me a sample query to run. So it's going to say, run this query, and the documents that are returned are going to be the documents that will match the rule and will be copied into the Atlas online archive bucket. It'll also recommend to define a index on that field that you use for the date field, and you can click on begin archiving, and this will set up the backend for you. One thing to note, and perhaps one of the great features of this, is if I click the connect button, and let's say we're connecting through Compass, for example, it provides us, as it does all of the MongoDB Atlas clusters, a really easy way to connect to the cluster through the connection string. So here it says connect to cluster. I can just copy this down and paste it into Compass, and away I go. I can also connect to the online archive if I want to query just the data that's stored in the archive, or I can connect to the cluster and the online archive. So from a single connection string, I can issue a single query that will seamlessly query both the warm data in Atlas cluster and the cold data that's stored in my online archive. Up until now, we have talked a lot about data movement within Atlas, but what if I wanted to visualize my data in MongoDB? I could use a tool like Power BI or Tableau to import the data, but with MongoDB Atlas, you don't need to do all that. Just spin up a chart. So I'm clicking on the Charts tab in the Atlas UI. And first, what I need to do is tell Charts what data source I'm interested in creating a chart from. So I'm going to click on the Data Sources button. I'm going to click on Add Data Source. And you'll notice my 3 clusters are here. I'm going to select my webinar. I'm going to go down to the stocks collection, and I'm going to check on my consolidated stocks. Click Finish. For those of you with a keen eye, you may have noticed that the time field coming from Kafka was written as a string. In a real app, you might want to store this as an ISO date, but here we wanted to show you some of the features within Charts, namely the ability to find a pipeline query that will be used as the data source for your query. So as I have it set up right now, whatever's in the collection will show up as data in the chart. But I can add a pipeline, and I want to fine-tune that query or the data that's available to my chart. So I want to basically add that field that is the date itself in a date time format. So I'm going to click Save. Now, anytime a chart is accessed with this data source, it will run through this pipeline. So let's go over to a dashboard and create a chart. So I'm going to click on Add Dashboard. This is my stock dashboard here. I'm going to create that. I'm going to create a chart in this dashboard by clicking on Add Chart. And the first thing I'm going to do is select a data source. So here is my stocks.consolidated stocks. It's sampling the data source, going to provide some of the capabilities here. I'm going to come down to a line chart continuous query. And so now I'm going to find what I'm going to have for my X and Y axis. So I would like to have on the X axis time. So I'm going to drag time here. I'm going to drag price on the Y axis, and I'm going to drag company name to group by as a series. So now it's going to update the chart. And what you'll notice is that when we ran this demo, we ran it over a couple of different days. So the data is kind of choppy because right now it's looking at all data in all time. So we have some data that happened earlier in May, like I think this was May 1st, and then a whole bunch of time when the demo wasn't running, and then we had data over here in May 2nd. So just like I could add a pipeline to the data source itself, I can further add another query here where I can say only show me the data in May 2nd of 2021. So I'll click Apply. And what that's going to do is now apply this filter to my chart here. And you can see that when we ran this demo at about 10:30 p.m., it started to create some sample data here, and we have zoomed in effectively on our chart. I can also do things like add a title and a description. So here's my stock price chart, and I can click save and close. So we can take this chart, we can share it. We can also embed this chart. So say I had a company intranet where I wanted to publish this chart, or even in the internet, we can actually lock it down from authentication and provide authentication to charts, for example, and embed this chart within your web page. So today I've barely scratched the surface on all the features and capabilities that MongoDB Atlas provides to you. I encourage you to check it out and use the promo code Kafka100 for $100 in Atlas credit to help you get started. Ethan and I would like to thank you for taking the time to watch our presentation on the Confluent Cloud and MongoDB Atlas. Today we showed you the Confluent Cloud, a completely serverless and reliable way to leverage a complete Kafka environment in the public cloud of your choice. We showed you how easy setup is of the MongoDB connector as both a source and sink for data between MongoDB and the Kafka topic in the Confluent Cloud. Once data is in MongoDB Atlas, you saw some of the possibilities, including searching the data using the Lucene-based Atlas search, querying both warm and cold data seamlessly with Atlas Online Archive, and finally visualizing your data with MongoDB charts. We have provided promo codes for you to get started with your project. In MongoDB Atlas, you can spin up a free forever tier or use the Kafka 100 promo code for $100 in credit to leverage production-ready clusters. For the Confluent Cloud, use the promo code Mongo200 to get up to $200 in credit for 30 days after the code is redeemed. The Mongo200 code is valid until July 31st of 2021. Again, thank you for your time. We appreciate it.